You are welcome to today's mathematical induction class. Now in this class, we want to prove this mathematical statement whether it's actually true or false. Mathematical induction is used to prove whether a mathematical statement is true or not. Now we have to show the following series by inductions. Yes, in mathematical inductions, there are three major steps used for solving this kind of a problem. Now the first one is the basic step, which you call let n equals to what? 1. The first one is a basic step, which is to let your n equals to 1. But before we go to those steps, I will show you some things in mathematical induction. Now if you look at this series, you will see an equation at the left. You also see an equation at the right. This equation at the left is used to get each of these values, each of them. That is, if your n equals to 1, it will give you this first value. If your n equals to 2, it will give you this second value only. If your n equals to 3, it will give you this third value only. But this equation at the right is not the same as this equation. This equation at the right is to get the sum of this series. But the only condition there is that whenever your n is equals to 1, this equation at the right will give you this first one. This one also will also give you this first one. But when your n is equals to 2, this will only give you this second one. But this one will never give you only this. This, if your n is equals to 2, it will give you 6, yeah, using this equation. But if your n is equals to 2, it will not give you 6, because this with what? Sum. So it will give you the sum of the first two. The sum of the first two, which is 2 plus 6, that will give you 8. So that's what this will give you. If your n is equals to 3, this will only give us this value only. As I've said, I said this is used to get each of them. Why this is this with what? This with sum. So this will only give you if your n is equals to 3, it will only give you this third one only, which is 12. But this, if your n is equals to 3, it will not give you 12. It will give you the sum of the first 3. You can try that as you are listening. You can try that in your rough book. Okay, so but we normally use n equals to 1 for the basic step, because whenever your n is equals to 1, the first term, this will give you this same value, and this also will also give you the same value. But when your n is equals to 2, the value this will give is different from what this is different from this. Okay, so when n is equals to 1, we substitute 1 to the equation here at the left and 1 to the equation at the right, whether they will give us the same thing. So for the left hand side, okay, we say let's n equals to 1, which is the basic step. For the left hand side, this is the equation at the left hand side. We have, for the left hand side, we have what? N squared plus n. And if I replace n with 1, I will have what? This will be equals to what? 1 squared plus 1. And this will give me 1 squared is equals to what? 1 plus 1. That gives me what? 2. That is for the left hand side. While the right hand side, what is the equation at the right hand side? This is the equation at the right hand side. We have n into brackets n plus 1, close the bracket, open that bracket, n plus 2, close the bracket, all over 3. I'm replacing n with 1 equals to what? 1 into bracket 1 plus 1, 1 plus 1, close the bracket, into another bracket, 1 plus 2, 1 plus 2, all over 3. And this gives us what? 1 into bracket 1 plus 1, 2, open another bracket, 1 plus 2, 3, all over what? All over 3. 1 times 2, 2, times 3, 6. That is 6 over 3. And that gives me what? 2. Now you can see that for the value of n to be equals to 1, the left hand side gives 2, while the right hand side also gives what? 2. So as I've said that whenever your n is equals to 1, this equation at the left hand side, the value it will give us, and the equation at the right hand side will also give us the same value. Yeah, but when your n is equals to 2, it's not the same. So we can say that our left hand side is equals to what? Right hand side. That is for the first step. The second step is the induction step by assuming that n is equals to k. Now, this step now, we started from the first series here, the first member, second one, third one, up to this point. Now, we are replacing n to be equals to k here. It's just like you are coming like this. So now, we are replacing n to be equals to k here. Anywhere you see n, you replace it with k. So at the left hand side, I will write all this. Why am I writing all this? It's because if you notice the first one, when we said n is equals to 1, it was just only this we got as the value. So I don't need to write all this. I don't need to write all of them. It was just only this first one we got, and the value is already here. So I don't need to write it. But when I say n equals to k, if I replace here to be k, I will need to write everything out because we don't know what k stands for. So here I have 2 plus 6. Okay, the second step, sorry, is to let n equals to what? K. Second step is let n equals to k. So here I have 2 plus 6 plus 12 plus up to. Now I'm replacing n here with k. So here we have what? K squared plus k, close the bracket, equals to. At the right hand side, I'm replacing n with k. This will give me k into bracket k plus 1, open another bracket, k plus 2, close the bracket, all over what? All over 3. Now this is our second step. The second step is not that, it's not usually long. This is just it. So we move to the third step by saying that let our n equals to k plus 1. This is where most students get confused. But pay maximum attention, you will understand the secret here. So the third step is to say that what? Let n equals to what? K plus 1. Now at this point, I'm replacing n to be equals to what? K plus 1. So I will need to write from here, but wherever I see n, I'll replace it with k plus 1. So at the left hand side here, I have 2 plus 6 plus 12 plus up to this point. Now, I'm replacing n to be equals to k plus 1. I want to show you one secret here. But before I replace, I cannot just jump to this point and just replace it with k plus 1. K plus 1. Why? Because if you remember what we did here last, our previous work here, we replace n to be equals to k first before k plus 1. So this was what I got here when I replaced n to be equals to k. I will need to write this back before I will now replace n to be equals to what? K plus 1. So here I have what? I have k squared plus k. That was when n equals to k. Then I will now replace n to be equals to k plus 1 using our formula here. So I will have plus, open brackets. Mind you, if you look at this clearly, you see that this n squared, that is k plus 1 square. So this will be, let me write it like this, k plus 1 squared plus, we have n here, so that will give me what? K plus 1 equals to, at the right hand side, I have this. So I will need to write this, change whatever I see n to be equals to what? K plus 1. So at the right hand side, we have k plus 1, open another bracket, k plus 1. I'm replacing this n to be equals to k plus 1. But mind you that there's another plus 1 here, so I will add it to it, which give me plus 1. Right, that gives me plus 1 into another bracket. I'm replacing this n with k plus 1. So if I replace this with k plus 1, there's another plus 2 here, which will give me what? K plus 1 plus 2. Everything all over 3. Okay. Now, if you look at this carefully, you will see that the value from here to here, or what we have from here to here, all of this is the same thing as what is here. If you look at it, 2, 2, 6, 6, 12, 12, this. So what we have from here to here is the same thing as what we have from here to here. And all what we have from here to here is equals to this, right? If from here to here is the same thing as from here to here, right? And from here to here is equals to what? This. Is equal to what? This. So I would therefore replace from here to here with what? This. Mind you that this value still remain. I will replace from here to here with this. So here I have k into brackets k plus 1, close the bracket, put under bracket k plus 2, close the bracket, all over 3, plus I just replaced only from here to here, so I will still need to add this, plus open bracket k plus 1 square plus k plus 1. Okay, let me just circle this, put everything here, equals to, at the right hand side we have k plus 1. Now we have k, 1 plus 1 will give me what? Plus 2, plus k, 1 plus 3, 1 plus 2. 1 plus 2 will give me what? Plus 3. Everything all over what? All over 3. Now, I want to prove this my left hand side to be equal to this right hand side. So I will need to bring out my left hand side out here and prove it. So I have what? K into bracket k plus 1, k plus 2, all over 3, plus brackets. Here, this k plus 1 square is same thing as k plus 1, k plus 1. So this is the same thing as this, plus this k plus 1 here, k plus 1. I hope you are following. So I can say this, everything here is all over 1, right? So if I find the LCM of 3 and 1, that give me what? 3. That gives me 3. So 3 divided by 3, 1. If I use 1 to multiply all of this, I will still get this, which is equals to k into brackets k plus 1, open under bracket k plus 2, close the bracket, plus, now 3 divided by 1, that is equals to 3, right? If I will use 3 to multiply this, at least let me just put the 3 out here, 3, 2 brackets, here I have what? K plus 1, k plus 1, plus bracket k plus 1, right? Okay, so if you look at this very well, okay, let me put the bigger bracket here. So here I have k into bracket k plus 1, under bracket k plus 2 plus 3. Now if you look at this and this, you see that k plus 1 is there, k plus 1 is there, so it's common in both. So I'll bring it out just to factorize it. I will have k plus 1. Now when I bring k plus 1 out here, I'll be left with what? K plus 1, k plus 1, plus, if I bring k plus 1 out here, what I'll be left with what? 1. Okay, all over what? All over 3. So here I have k into brackets k plus 1, under brackets k plus 2 plus 3 to bracket k plus 1. So here I have what? Now here, this k plus 1 plus this 1, if I open the brackets here, that will give me what? 1 plus 1, it will give me what? 2. This will be k plus 2. Everything all over what? All over 3. Okay, now you still see that this still the left hand side. I want to prove it whether I will get the value for this right hand side here. So let me just finish everything here. Let me complete it here. So here I have. Now if you look at this and this carefully again, something is common here and it's also common here, and that is what? K plus 1. K plus 1. So if I bring out k plus 1 out here, I will have what? K plus 1. If I bring k plus 1 out here, I'll be left with k into bracket k plus 2. So I'll be left with what? K into bracket k plus 2 plus, brought out k plus 1, right? So if I've already brought out k plus 1, so I'll be left with 3 into bracket k plus 2 here. 3 into bracket k plus 2. Everything all over what? Everything all over 3. So here I have k plus 1. Now, you will see that something is still common here again. That is k plus 2. So I will need to factor out k plus 2. So I'll bring it out again. I will have what? K plus 2 to join this one. So if I bring k plus 2 out here, I'll be left with what? K. I'll be left with k here plus. If I bring k plus 2 out here, I'll be left with what? 3. Everything all over what? All over 3. So here I have what? K plus 1 to bracket k plus 2 for under bracket k plus 3 all over what? All over 3. Now we can see that this is what we actually got from our left hand side, right? You can see that what the value here for the left hand side is now equal to the right hand side here. So what does that mean? It simply means our mathematical induction is what? Is true. Since left hand side is equal to what? Right hand side. Therefore, the mathematical induction is true. It's true. This is the voice of Tutor Ayodele. Tutor Ayodele. Stay tuned for more tutorial videos. Consider to subscribe, like, comment, and share to your loved ones. See you in my next video. Thank you.